but you can prove them in a few different ways in here, and this first way hopefully was the way that you solved this problem. Raise your hand and tell me what you did to do this. Mallory. So that's called factoring, right? So factoring is one way to prove a zero. So pulled out an x, and then you were left with x squared plus 9, right? Okay, then what do I need to do with each of these pieces? Set them equal to 0. So this first one's just going to be x equals 0. Is there any work there? No. That's proving it, by the way. If you factored it and set it equal to 0, that is proving it. Let me go ahead and do this one. X squared plus 9 equals 0. So to solve that, we will subtract 9 from both sides. And then what do we have to do after that? And when you take a square root, what do you have to put in front of it? Okay, now, I don't want to leave it plus or minus the square root of negative 9. What's the square root of 9? What's the square root of a negative? So it'd be plus or minus 3i. That's how I want to be left. Does that make sense? How many zeros are there altogether? 3. 1, 2, 3. What's the degree of this exponent? That is how they match perfectly, right? 3, and then 1, 2, 3. 3. You proved these, by the way, by factoring. So that's one way to find and to prove zeros. But not everything is nice and pretty and able to be factored. So here's our next problem. Take a minute, go ahead and write it down. So I'm looking at this problem, and I'm trying to find the zeros and prove them, not just write them down. Can you factor that? Now, I could try to do the double dating method. That's where you break it down the middle, but it doesn't factor. Or maybe you forgot how to do that. So what's another way that you could find the zeros? Graph it. Go ahead and graph it. You've got a calculator, so we're going to graph it right in that calculator. X cubed minus 5x squared. X cubed minus 5x squared plus 2x plus 8. Uh-oh. Oh no, my graph looks all weird. So what are some ways that what are some things I need to do to fix this first off? So that it doesn't look weird on mine. So to turn off your scatter plot for anybody, in case it ends up being on yours tomorrow and you want to fix that, you go to second y equals, and you go to number 4, plus off, and click enter. You should see the word done. Notice I also was not in a 10-10 window. Can somebody else tell me how to get back to the 10-10 window? Not window. I mean, I could. Zoom and then standard. All right. That puts me back to the 10-10 window. It's actually more helpful if I'm in that pretty little window. Okay, so what is one of the zeros? Raise your hand and tell me one of them. Negative 1. You guys agree? Now we have to prove it. What way have you learned in here that you could prove a zero? That we did a while ago, like last week. That would be the way I could find it on the calculator, but that doesn't prove it. What's another way to prove it? What's something you did in here last week? Well, synthetic division, right? So we're going to prove it by using synthetic division with negative 1. We're proving it. What does my remainder have to come up to be for me to prove it? 0. This is the algebraic way to prove it. Just because you saw it on the calculator doesn't mean it's 100% true. So 1, negative 5, 2, and 8. I'll bring down the 1, negative 1, negative 6, 6, 8. I did that rather quickly. Mainly because we've practiced this a few times now, right? Okay. So, what could I do with this now? I've got two options now. You proved x equals negative 1. You proved it, we're set. How Okay, so Sparta's saying I could use 2. No, Sparta, I'm too lazy to go back up to the top. So I could actually just do it straight from here. Now, is there something else I could do instead of synthetic division? I could rewrite this and factor it, right? So I'm going to show both ways. I'm going to do Sparta's synthetic division. 1, 2, negative 4, negative 8. That gives me 0, right? Because once you pulled out the 0, you can keep pulling them out from that same function. Now, the other way that Whitney said was I could factor this. X squared minus 6x plus 8. And that would factor into x and then set those equal to 0. So I get x equals 4, x equals 2. Okay. Now, if I do Whitney's way, that proved all 3 right there, right? I would only technically have this line of work and then this line. Now, if I decide to do Sparta's and continue, I only proved the 2. What else do I still need to prove? 4. So I can do that right here at this line. Bring down the 1. And I get a 0. Now, I don't care which way you decide to do, but they're not all going to come out nice and pretty where Sparta can easily do all 3 this way. So he's probably going to have to factor at some point or set it equal to 0 at some point. Okay? So we just proved 3 zeros. X equals 4, x equals 2, and x equals negative 1. We proved it because we got the remainder of 0. So all I did, Sacco, was I took those x's and I put them into synthetic division. I used it. I used that line and I came up with a new polynomial. And then I just continued using my synthetic division. Now, could I have gone back up to this original line and did the 2 that way and done the 4 up in the original line? Yeah, I could have. And I would still get 0. So either way, I've got lots of options here, right? That make sense? Lots and lots of options. Okay. Here's our next one. So now that you've written it down, what are some of my options I have to do this? What? Graphic, that's one option. You know there's actually another option? You could do that also, yeah. You could either factor this right from the beginning or graph it. I'm going to go with graphing just because I've got the calculator. It's a great tool. Let's make sure we use it, right? So, x cubed minus 15x squared plus 75x. Oops, too many there. Minus 125. Notice mine's thinking, it's thinking, uh-oh. Uh-oh, it's not popping up. Let's see. Oh, I forgot my x. So if you don't see it right away, maybe you want to double check, did you actually enter it correctly? Sometimes you mess up. So now it's thinking, hopefully it grabs it. There we go. Okay. So what x value does it look like it's going through? Looks like it's going through 5, right? Well, let's check. Let's see if that's the case. So what do I have to do with this? Synthetic division. I could, but I still have to prove it algebraically. So I'd still have to do the synthetic division. So if you want to like double check it that way, that would be fine. So maybe 5, 1, negative 15, 75, negative 125. All right. John? Oh, I messed something up there. Oh, that should be a positive 25. Good call. Good call. Do you see any other zeros on the graph? So it's not like I can just look at the graph like Sparta was able to on the last one and continue doing my synthetic division, right? So if I can see all of them, I can prove them all using synthetic division. But if I don't see them all, now I have to go with Whitney's method, which was factor, right? So I'm just going to be factoring x squared minus 10x plus 25. Now, my question before we actually do this, do I have to factor or do I have another option? Well, regraphing actually may not help me. Like, regraphing may not help me on that case. But factoring was one option you guys said. What's another one? Especially if it's in this form here. The double dating only works in the top form, not the bottom form. It may have a multiplicity. That may be something we're going to be finding out here. And that's what we'll be seeing here in a second. But let's say you couldn't factor this. What's the other option? What did you do on this weekend's homework? What? Quadratic formula. So if it doesn't factor nicely, you may have to do quadratic formula. Do you have to do quadratic formula on this one? No, so I'm not going to. X minus 5. X minus 5, so I get x equals 5. And I'm actually just going to write with a multiplicity of 3. That make sense? Because I actually have 1, 2, 3. See how I have all 3 of them? That's why I'm going to say the multiplicity of 3. Notice it does go through at 5, doesn't it? It doesn't just touch at 5. If it touched at 5, what kind of multiplicity do I have to have? Even, right? So it could be 2, could have been 4. Well, it couldn't be 4 because that's too high the next one. Okay, does that make sense to everybody so far? All right. So while you guys are working on this one problem, I'm actually going to start it up here. Because I'm walking around, it looks like most of you are understanding. I'm going to start with negative 3, 2, negative 9, 18, 71, negative 30. 2. Well, where did you learn this first? You did, yeah. So I found negative 3 works. Then you guys found 2 probably, I'm guessing, right? Negative 22, 5, positive 10. And then you found what other number? 5. Then down, I get 2, 10, negative 1, negative 5, 0. Okay. Now, Sparta actually pointed out, hey, I noticed that it goes through a fraction. I said, well, take care of the whole numbers first. Don't worry about the fraction at all. Just take care of the whole numbers. Now, at the end, you may have been able to figure out the fraction was 1/2, right? So if you want, you could actually prove it this way. Bring down the 2. 2 times 1/2 is 1. Okay, that proved it, right? Or, at this stage right here, I'm going to have 2x minus 1 equals 0. I'll add 1, divide by 2. Either way there would prove that. Whichever way makes you feel more comfortable, right? That make sense? So how are you guys doing with the proving these? Pretty simple? Go ahead.
All we have to do is do all this. We don't have to do anything else. And then even though it's 1/2 and 5, and then we can make it 3, or we can do this.
Yep. Now, at some point in here, like at this stage right here, I could have factored it and found 5 and 1/2 if I wanted to. Maybe I want to try to break this down the middle, and then I realize, well, that's not going to be pretty, so then you have to make that decision. Do I want to keep going and factor? Can I just find all the zeros and do that? Make sense? All right, we're going to skip that one for now. Let's do this one. We've already got our calculator. We're going to write a polynomial with zeros of 2 and 7i. Now, in order to find this, we have to know one other thing. 7i. Is it possible to only have 1 0 with 7i? He needs a friend, doesn't he? What's his friend? Yeah, you have a plus 7i. You also need a minus 7i. Anytime you have an imaginary one, he also needs a friend. Because the only way you could have got the imaginary number was to take the square root. In order to take the square root, you have to put plus or minus, right? Okay. Now you did this again once before in algebra 2, but it's been a long time since you've seen it. So the way we write this out is we write x, we use the opposite sign. So right now this is a positive 7i, I'm going to use minus 7i. This is a minus 7i, so I'm going to use x plus 7i. I like to write the two imaginary parts first, and I'll explain why here in just a second. But what am I going to write for the 2? Okay. Now, the reason I like to write the two imaginary parts first is that I'm going to FOIL them together first. And when you FOIL two imaginary pieces together, the imaginary parts should disappear, and you should be left with nice, pretty real numbers. Go ahead and FOIL these first two together. So, just here in my first two groups that are up front, you guys got it. X squared plus 49, right? Now, go ahead and FOIL that with the x minus 2. So you FOILed the first two together, you still need to FOIL the last one. Justin's sitting in the back being like, yep, I'm good. So let's go ahead and FOIL these two together. So I get x to the third. I'm actually going to multiply these two. Minus 2x squared plus 49x minus 98. Oh, good call, Justin. Thank you. All right. Now wait. You want to double check yourself very quickly. Now I'm not saying refoil it or anything like that, but I am saying graph that real quick. How many times should you see it touch the x-axis?
3.
Now?
2.
Now?
1.
1. 1, right? At what point should it touch? 2. Because can you see it touch 7i and negative 7i? You can't see that, right? It's imaginary. So the only one you should see it touch is 2. Do you see it touch a 2? Good, you did it right. You like that? That's a nice check, right? All right. So at this time, there's about 10 minutes left. I'm going to tell you now, you need a calculator to do this homework. And we're going to skip all this stuff. And here is your lovely essential work due tomorrow. So I'm going to give you time right now with the last about 12 minutes of class to work on it.